density is a measurement of your physical appearances, or not physical traits of a substance. So this would be a interior one, to where regardless of the amount of substance you have, it's always going to have the density. So for instance, aluminum, a student has a sample of aluminum that has a mass of 27 grams, a volume of 10 centimeters. What is the density of aluminum? So basically, we just take our mass and our volume, we take our 27 grams divided by 10 cubic centimeters, or 1 milliliter, and then you have your density, because your density is just 2.7 grams per centimeters cubed. So you have your grams over your volume, so your mass over your volume is density. With that being said, since density equals mass over volume, that means we just need to switch it up. So if I look at it, I would basically do my algebraic equation. I need to multiply both sides by mass and divide both sides by density. So that means that I basically have my mass equals density times volume. Okay? So now, if I have volume, I will have volume equals mass over density. That's what I get. Alright? So, with this consideration, we're always going to have mass on top. Density and volume are multiplied together to get our mass. Alright? So, going into it. Calculate the density of a material that has a mass of 52.457 grams and a volume of 13.5 centimeters. So we know that density equals mass over volume. So we take our density equals 52.457 grams. We're going to divide that from our 13.5 centimeters. If we take our trusty little calculator, we take our 52.457, divide that by a 13.5, and we get our answer. So we have a density of 3.89 grams per cubic centimeter. And just one thing to remember, cubic centimeters equals 1 milliliter. Alright. So let's try another one. A student finds a rock on the way to school. In the laboratory, he determines that the volume of the rock is 22.7. The mass of the rock is 39.94 grams. So even though it's in reverse, we still got mass over volume. Density equals your 39.943 grams over our 22.7 milliliters. So we get our answer of, get our trusty calculator, we take 39.943, divide that by 22.7, we get our answer of 1.76 grams per milliliter. And remember that milliliter equals those cubic centimeters. Now think of density as a relationship between mass and volume. So you are a specific mass and your volume of your body is a specific length, width, and height. So, and that's where the cubed comes from, by the way, for volume. If you were to look at all the objects in your room, so think of your room or your living room or your kitchen, And what if you made your room half of the size of what it would be? What would you have to do with all of your furniture? Would it all fit in the same way? Would you have enough space to walk around? Or would you have to throw everything on top of each other and hope it still fits? So you're not allowed to take anything out of your room. You have to keep it in your room. So let's do a nice little thing. So let's say your room is this big, and you have your bed, your dresser, your TV, your desk, your chair, and your closets here with all your clothes in it. You have your door to get in the room. You have all of your, let's say you have, I don't know, a table or a nightstand right here. So now we have to fit all of this stuff that's normally going to fit in here nice and easy, and TV table, whatever you got going on. Now we have to put it in a room that's this size. So this no longer exists. What are you going to do with all your stuff? So think of density as more particles are being shoved into a smaller space when it's a larger density. You have a much larger mass for a smaller area, so the larger something is, you're going to have a lot more stuff shoved in there. So think of it along this lines. This is what's going to happen. So if you've ever seen like the first Star Wars, A New Hope, where they have the trash compactor scene, the reason why it's scary is because you only have so far to go. If it's compacting something, the volume of the room is changing, but your mass is not. So at some point, something's going to give, and that's not a good thing. So that's why when we think about density, think about not just all this number stuff. Think about how we have all these particles. So all these different particles for an object that are in a much tighter space, because you have a lot more mass for something like titanium than you do for something like oxygen. Think about the object it is. If there's a lot more mass per atom, you're going to have a lot higher density, because that same volume for both atoms is going to be much different based on the mass that you're given. All right. So just a little chemistry tie-in for what density works. Go ahead and finish this worksheet, and then we will go about doing our lab for density later next week. All right. Have a good day.